Hello everyone, welcome to AI Anytime channel. In this video, we are going to have a look at Vectra. So Vectra is a new developer-friendly API-first platform that helps you perform natural language processing tasks. Vectra is powered by large language model. Okay. It's also a new alternative to Pinecone, which is very famous for vector databases, vector store, and that can help you perform semantic search, question answering, chatbot, and other natural language based tasks that we have seen in the recent times. So Vectra has now also been integrated with Langchain. So in this video we are going to see that how programmatically we can utilize Vectra, their embeddings, the vector stores through Langchain. So we'll build a simple Streamlit application and where we'll upload a document and we'll ask some questions to retrieve the information. So if you currently see, I am on Vectra here, which says build products that speak for themselves. Okay, and not just another chat GPT for your data. So we have seen a lot of tools and platforms which says that you can inference on your data. We have seen private GPT, we have seen local GPT, we have seen mini GPT, we have seen XYZ GPT, all using Langchain embeddings LLM. That's the workflow, guys. Okay, but what's so good about Vectra? That's what we are going to discuss. So Vectra has something called, if you come over here, it has something called grounded generation that eliminates hallucination. What is the most important constraint at this moment when we talk about large language model? It's hallucination. The large language model hallucinates a lot. Okay, and when you talk about open source language models, they hallucinate more because they are not that contextual in their answering, that they are giving you the responses. Okay, there are the issues with the context that we have. Okay, so we have to look at the context, okay, and the responses that we are generating. So open source language model has more issues with hallucination. There are many reasons for that. Okay, when we talk about closed source language model, for example, GPT-3 or 4, they have been trained on something different. When we talk about the architecture, they have RLHF into it, and we have, when you talk about open source language model, a few of them are RLHF. For example, stable Vicuna is a RLHF based it follows the RLHF based architecture, but many of them don't follow an RLHF based architecture. And these are not only the reason for hallucination, there are other reasons for hallucination. That's why this language model hallucinates. How can grounded generation helps you to eliminate the hallucination? Maybe we can look at the context of it on a very local level. Okay, that's what grounded generation provides. If you come below, you will see that the same exact thing that Pinecone also shows on the website or the platform when you go, like semantic search, similarity, etc., summarizations, question answering, whatever that you talk about it, right? But they are saying introducing grounded generation by Vectra. So if you click on learn more, okay, if you come over here, you will understand more about grounded generation. Okay, it's loading for me in this case. So generative AI has changed everything. Indeed they have. So now get summarized answers, say goodbye to hallucinations, say hello to grounded generation. Okay, so you can read about here. They don't know answer to your questions about and some lexical searches provide more relevant answer than solely semantic searches. Very important crucial point when it comes to language models. Okay, lexical searches provide more relevant answer than solely semantic search. Okay, grounded generation remedies all of this. So if you see here the image that they have explained it. So you also have opened the diagram over here that how Vectra basically works. So you have data ingestion workflow, then you have query workflow. So in data ingestion, extract, embed, index. When we say about the extract, so Vectra automatically extracts text from documents, that can be any source of document, and chunk the text in an optimal manner suited for grounded generation. Okay, so Vectra's state-of-the-art embedding models are optimized for high precision retrieval, okay, of the most important facts. Then they store in a vector databases. Okay, that of course for optimized for low latency, it has inbuilt similarity searches, algorithm, etc. into it. Then they have query side, they have retrieval. So recall candidate results from millions of documents in real time, just like Pinecone, for example. Summarize, optionally generate a natural language summary of the top result, and then you perform QA on that. Okay, so it generates the summary, it has a context out there, and then you ask a query that large language model goes to that context or this basically the summarized text that Vectra has retrieved for you. Language model performs the inference on that, and then you get the response. That's how Vectra currently shows from the high level diagram that they have given on the website as well. So you can read more about grounded generation. They have patented as well. You can read that here. Vectra's patented use of multiple LLMs constrains question answers to your data, not from training set of generative model, all but eliminating hallucinations. So this is a patented technique, guys, that Vectra provides. Okay, mainly is the summarize. So summarize, you can read it over here, and the citations, of course. No, citations is not a big deal. So now if you read, so grounded generation is not a new concept. It has been used earlier in the chatbots. Okay, so you can read more about here. Simple summarization, etc. Avoid hallucination. Privacy, your data is yours, because we're talking about more controlled language model, that from privacy and governance, etc. So here is how it works. But your data is yours, because they have if you come over here, you can have to click on get started free. I already have created an account on it. You can let me come on my account. You can see this is my account, AI Anytime. I will go on overview. When you create your account, you will be headed to this page, overview. Okay, and in the left hand side we have something called corpora, authentication, API keys, and billing. So they provide free also, but billing, you can see you can scale and growth. They have two different types of it. You can put your card if you have multiple documents you want to utilize their services at scale. A lot of features are there, you can explore that. Okay, now on authentication, I'm not going into the API keys. I have created API keys here. Okay, so first thing that you have to do on overview, you have to create a corpora. So I already have a corpora called Langchain demo, but here you can click on the right hand side top, create corpus. So when you click on that, you can see here you have to give a name and you have to give a description, and then you have to click on create. So I will not create it because I already have a Langchain demo here. When I click on Langchain demo, it will take me here, guys. Okay, you can see you have your uses, overview. If you click on authorization, you will see your API key. You can also ingest data directly. So if you don't want to do the data ingestion programmatically through Langchain, for example, you can directly do it here. So you do it here, you index it here. So Vectra will index it for you. You don't have to do anything, and you just consume the API, put it in a UI like a React, for example, or anywhere you want, and you can make the inference. Okay, so that also you can do. You can see the file upload API, the indexing API, everything has been given. They have a very good documentation as well. Let me do a right click and open for you. You have to come here and click on overview of APIs. You have gRPC and REST, for example, whatever flow that you want to use there. Okay, whatever methods that you want to follow, you can do that. Then you have search option. You can search right there on your document. You can do that as well. I'm not going to do that here. I'm more interested on programmatically here, that how we can do it programmatically with Langchain. Okay, so we're going to combine Langchain with Vectra. Okay, so Vectra is an alternative, a very powerful alternative to Pinecone. I do believe that. Okay, I'm not going to say that Pinecone will be will not be used after this. There is a separate fan base for Pinecone. Okay, I also use myself. Okay, but this is a very good alternative that looks like with grounded generation that they have, guys. This is how the platform looks like. This is the platform. You have one corpora Langchain demo. You can have multiple corpora. You have ID, size, etc. What all those things are okay. Now here is the thing. Langchain does the heavy lifting for all of us. Okay, so if you come over here on Langchain, you have to go inside indexes. In indexes, you have to go into vector stores. You can find out all the vector stores, open source, closed source, whatever is available inside Langchain, the ChromaDB, the Phase, the the OpenAI, the LambsDB, Milvus, Pinecone, Qdrant, etc. In below, you will see something called Vectra here. So Vectra, here the documentation, everything remains same. Text loader, loading for text, PDF loader, PDF, whatever file you want to load, that will flow in. Then you have character splitter, recursive or text character or character text splitter, whatever you want to use. Then the embeddings will come in. For embeddings, we are going to rely here on Vectra, and once we have the embeddings, okay, we'll pass that to OpenAI GPT-3. Okay, GPT-3, maybe DaVinci we are using. DaVinci Text 3 model. I think this GPT 3.5 Turbo you can also use if you want. Okay, this is what we are going to use here. So let's write it programmatically, and we are going to use, maybe you can use any document, but I have this document handy with me, state of union txt. This is like a State of the union is like a gadgeted document now for language model inference. Okay, so we are going to use state of the union. You can use PDF, doc, whatever document you want to use. I have a requirement file. You can see, let me open that in VS Code, guys. So let me just do one thing. I'll open in terminal. Now let's start writing the code. I'm going to create a simple Streamlit demo where we will create a question answering tool. So this will be a question answering tool. We'll have our question based on the document that we are uploading. We'll ask question, we'll get the response. That's what we are going to do with the help of Langchain and Vectara. Okay, so let's do that. Here what I'm gonna do here is gonna just activate the virtual environment cdvenv. If you haven't created a virtual environment, you can do that. If you want to do inside Anaconda, that's also fine. cdvenv, and the next is cd scripts. I'm just gonna activate this. So activate cd dot dot, a couple of cd dot dot, and then let me open that in VS Code. So when I open in code, what I'm gonna do here is, so you can see we have state of the union text. We have the requirements txt. I'm not gonna open env file which stores my API keys for both OpenAI and the Vectra. So I'm not going to do that. I will of course give the sample file that how it looks like on my GitHub repository, then what kind of constant or you have to define there, because they are not going to change the API key. So I'll give you the naming convention that how I have done it. Maybe that can give you a reference point. Langchain we need. Okay, we need Chroma. We don't need ChromaDB. Okay, let me just remove ChromaDB for now. Okay, because we are not going with ChromaDB or open source native vector database there or vector store. We don't need it. So Langchain, Streamlit, Python.env and OpenAI. That's what all we need. Okay, here in this case. Let me just create an app.py. So here I'm just going to do app.py. I'm just going to do first import Streamlit as st, and let me just create st.title, and here I will just write Langchain plus Vectra demo app, something like this. Okay, this is what I'm going to do. Okay, this looks nice. And how do we run a Streamlit app, guys? So let me run that, guys. Okay, so I'm just gonna do Streamlit run app.py. So this is how we run an application in Streamlit. If you come over here, you will see Langchain plus Vectara. I think I have misspelled it. So let me just make it correct. Vectara. So this looks nice. Vectra demo app. And now what I'm gonna do here is let's have a file uploader. So file uploader. And in this I will have a file uploader where we'll upload a file. So upload your file, guys. So upload your file, and let's keep type as a txt. Even I upload state of union, but if you want to upload PDF file, please go and watch my previous videos. If you want the code directly, I have used PyPDF2 and PyPDF, or both of them. The code is available on my GitHub repository. Maybe if you are interested in PDF, go ahead and do that. If you don't want to use my code, go and use private GPT by I Martinez. That guy has all the code, at least from the Langchain aspect I'm talking. So if you have multiple file formats, you go to private GPT repository and you will get whatever you need there, at least the Langchain code. Okay, other logics you can write it, of course. So file uploader, this is what I'm going to do here on file uploader. Now we have the file uploader. Let's do, if file uploader is not none, let's see if there's a file, and then we'll have something like if st dot not button, it's okay. Let's do a pass for now. Okay, so if file uploader is not none, let's see how it looks. Okay, if it makes any changes. You can see now we have a file uploader on this Streamlit UI. Okay, so this looks nice. Here we can upload our file. Okay, so we are not interested in that one. Okay, at least this moment. So let's do one thing now. Okay, so now let's do the Langchain heavy lifting here. So what I'm gonna do here is I'm gonna say, okay, from Langchain, the first thing, document loader. So document loaders, we need import text loader, because we have a text file that we are going to upload, and we have checking with the txt extension on Streamlit. Okay, but if you have PDF, you have doc, you can use PDF loader or PyPDF loader or whatever you want to load. Go through the Langchain documentation to get that, guys. Now the next thing that we need is from Langchain dot text splitter, import character text splitter. We need character text splitter. If you want to use recursive, also you can do that with the chunk size and overlap. Maybe you can explore that. Okay, and please watch my previous video, guys. I will give some of the videos link in the description of this video, the other LLM videos that I have. where you will find similar code. The flow remains the same: file loader, embeddings, language models. If you have a prompt template, you can define it as well. So that's the flow remains same, guys. Okay, it's not a rocket science. Multiple models are being released. Go to Hugging Face, open leaderboard, see which model you want to use, go through the documentation. Of course, your logics comes in, your domain knowledge comes in play. If you want to make it faster, don't use transformers, use C transformers. So these are the things that you should know, and you will find it in my previous video that I have done it. Okay, maybe that you can find it on the playlist, and go through the playlist and find that videos. So characters text splitter, Langchain.text splitter is done. Now the next is embeddings that we need. So from Langchain, not embeddings, so vector store. So vector stores import, and for that we're gonna use Vectra here. So you can see it's suggesting me Vectra. So now we have vector stores. We also need OpenAI LLMs. So how do we do that? So from Langchain.LLMs import, pretty much straightforward, OpenAI. If you want to use a close open source model like Vicuna, Llama, Alpaca, etc., you can also do that, but make sure that you have high computational power or a VRAM to run that. Maybe on Mac CPU you can also do that. Okay, these models, 7B model runs on those. Okay, you have to look at the floating point, which one you are going to use, which quantized model you are using. So from Langchain.LLMs import OpenAI. Now what I'm going to do here is from Langchain dot, we need retrieval, so let's use chains here. So chains import, I'm going to use retrieval QA, and I need a couple of utilities. So import OS, import from .env to handle the env file where I store my API keys. From .env import load.env. So we have load.env. This looks nice. I think we have everything now. Now what I'm going to do here, I'm going to initiate the load.env to pull all the API keys from the env file. So how do we do that, guys? So we do like this, load.env, that's it. Okay, now let's define those things. So OpenAI underscore API keys, and then this is what we do, os.getEnv, and in this os.getEnv we just pass OpenAI API keys here. So now we have Vectra customer ID, and in Vectra customer ID we'll pass customer ID. This looks nice, os.getEnv. Now we have Vectra, let me just copy it here, guys. I'll just copy this to make it a little faster. So this looks nice, Vectra customer ID. This will not be customer ID in this case now. So Vectra corpus ID, and then we have Vectra API keys, Vectra API key here. I know why I'm not getting the red color, because I haven't closed this. Okay, now this looks good, and this will not be customer ID, this will be corpus ID. I'll explain what those corpus mean, by the way. Corpus ID, and then we have customer ID, that will be Vectra API key here in this case, API key. This looks nice. So Vectra API key, Vectra corpus ID, Vectra customer ID. This looks okay. Now let me show you what I'm talking about. Okay, at least with this 4 line of code that I have written over here. Come back on the Vectra dashboard, guys. Langchain demo, the corpora ID, the corpus name. So the corpus name is your ID. Whatever you can see here on the left hand side, that's your ID. So in this corpus ID, this is Langchain demo. In API key, you will find that API key in authorization. I'm not going inside it. Okay, it's like API key, and customer ID is your email address. So whatever email address you have used to create that account on Vectra, that's what customer ID is. And OpenAI API key, that you will get it from OpenAI dashboard. So I hope you're familiar with that. Okay, now we have written the load.env thingy here. Now what I'm going to do here, I'm just going to write a function. Let's call Langchain, maybe call func, and let's have two things here. So one thing is file, and the other thing remains is question. So file and question. So we'll upload a file. Maybe you can also do it separately, but no, you can explore that. So loader, I'm just going to write it faster here. So in this function will take file as an input and a question as an input, the query that user will ask on the Streamlit app. Now in loader, what I'm going to do here, I'm going to just use text loader, and in text loader I'm going to pass file, and I'm passing a text file, so I might get encoding, so encoding error. So I might have to use encoding UTF-8 for the text file. I don't know why I'm getting misspelling encoding, and I think this should be UTF-8 for the text file. So we are done with the loader. What we are doing, we are loading the file here, guys. File the end user will upload. That's what it does. Now we'll create a variable called documents. Inside this document, we'll use loader.load. That will load that. Okay. It's a function. So let's write like this. Then we have defined a variable called Vectra. Python is the most easiest language, guys. Okay, pretty much self-explanatory everything you do. So now we have Vectra. So in Vectra, we're gonna pass not that. We're gonna use from documents, like we have done with other ChromaDB, fast CPU, whatever you use. Okay, and now here documents remain documents. This is correct. Now here on embedding, don't do anything, just pass none for now. Okay, let's use them by default. Okay, so none, this goes okay. And we have a variable called QA, question answering. In this we'll use retrieval. So retrieval QA, and in this retrieval QA, what we're going to do, we're going to use from LLM. We need a LLM there. So our LLM is nothing but OpenAI. Again, you can, and I'm going to use the default one. Okay, inside this you can pass now the model name, the max tokens, the temperature, everything you can pass it. But let's keep that for now. Okay, I forgot to write LLM here, for example. LLM is OpenAI, and our retriever. So let's write retriever. Our retriever is nothing but Vectra as retriever. So Vectra variable that we have defined on top, and then we use as retriever, which is again a function from Langchain. This looks nice, so we are done with it. Retriever. So we have a LLM. We are using OpenAI as a language model, large language model rather, and in the retriever we are passing Vectra.as retriever. So Vectra contains all the embeddings. Okay, there. And now I'm gonna just use answer. So in answer, I'm just gonna pass QA, for example. So in this, let's have a QA, and maybe we can print something in the terminal. So query, and then query remains, for example, that remains our question. So that question will come from the end user. Okay, so from the Streamlit app, where we have passed this question as a parameter, and then we're just gonna return the answer. So let's return the answer. So this looks nice, guys. So here what I'm gonna do, if I have to explain it, what I'm doing here is, we have file and question. So we have file and question, and then we have text loader, which kind of gets the file, and then we are using loader.load to load that file. Then we have retrieval Vectra from document. So we are using Vectra here with the grounded generation feature. So documents are being passed. Okay, embeddings are being created, stored, and then you have QA, retrieval QA from LLM, that OpenAI GPT-3 models are being used, and then retriever we are using Vectra.as retriever. So this is what function does, guys. Now let's do our Streamlit thing here. So let me just do that. So I'll just remove the pass from now. So if file uploader is not none, so let's have a file name. So I'm just going to call it, because we have to save that. Okay, in Streamlit we have to save it. We have to use the buffer of it. So we have to do get buffer. Okay, so file name, otherwise we'll get bytes IO error, guys. So file name, file uploader.name. This looks good. So file uploader.name, and then I do with open. This file name is okay. So with open, let's do os.path.join. So we join it. So os.path.join, and in path.join, then I just pass file underscore name, and then I pass w. So basically writing it. So this will be inside the string wb, and then I just do as a file. So as file, and then here I do f.write. I'm just writing it, f.write, and then we do file uploader.get buffer. So we are going to use this function called get buffer. Yes, that's it, guys. So we have done now this. So our question now. So let's have a question variable where we'll store the question variable. So we'll have a text area. So in question, let's write st.text area. And in st.text area, what I'm going to do here is, in this st.text area, let's have enter your query. So enter your query, and then, so now we have question. So this question, who will ask this question? The end user on the Streamlit UI. Okay, so we have a text area. We also have text input, but our text area looks a little bigger. You can control the height and width of that. Okay, so let's have a text area now. st.text. Now what next? So we'll have a button now. So if st.button, let's for example ask. our button name is ask, and if h dot button ask, we have, let's also check this, there's a question inside it. So if length question, not 0, let's call it greater than 0. Okay, so there should be a question inside it. Okay, and then we'll use that function. So let's use that function in a, let's have a variable called answer. In that answer, I'm going to use the function. Our function name is nothing but the Langchain function. So in Langchain function, I'm going to use file. So file is nothing but the file name, and the question is nothing but the question. So question remains the same. Our variable name is same here. So question, and let's for the user interpretability, let's have the question out there. So I'm just going to do your question, or maybe your query, and I'll just give some space. I'm just going to write here the question, and then for answer I will do ht.success, not question. Let's have your answer for that. So your answer, and then this remains answer. Let's have this answer and see what we are getting here, guys. Okay, this looks nice. So let me just give you a walkthrough of the code. We have imported all the required libraries and dependencies. We have stored all the environmental variables details like API keys of OpenAI GPT-3 model, and Vectra details like customer ID, corpus ID, API key in the env file. Then we have written a function called Langchain func, which takes two parameters, file and question. Maybe you can write a function for file separately, because not every time you have to load and ask the question, so the function will be executed every time for the file loading, but you can do that. Okay, then we have the loader, the text loader from Langchain that loads that file, and the loader.load passing the to document. Then we're using Vectra here. Here comes Vectra. Okay, the new generative AI platform. Vectra.from underscore documents, passing that document using embedding equal to none. Let's have a default by the Vectra. Then we have a question answering. Again, we are using chain there, retrieval QA chain. You have conversational you have conversational chain, you have retrieval chain. You can use those chain as well. Now, if you want to build a chatbot with memory, you can also do that. Okay, that documentation will be available on Langchain documentation page, and that's we're just using that function in the Streamlit. That's what we are doing. So now let's run this guide and see if we are getting any error or we get the desired response. So I'll come back here on app, and I'm just going to upload a file, state of the union, and let's see. And now you can see we got an option called enter your query. Here we will ask our query, guys. Okay, so let's ask the question. So this is state of union, like this ongoing year. So here we'll talk about, so if you read about this, they're talking about NATO countries, and they have been talking about Russia-Ukraine war and all. So we'll ask a related question and see if you're getting desired response. So I'll just maybe I'll ask, what did Vladimir Putin? Let me know if you're a fan of Putin, by the way. Okay, NATO will be of course against Russia. There's no doubt about it. What did Vladimir Putin miscalculate, something like this. Or let me just write according to the document. Maybe you can also use prompt templates to only get the information from the document. Otherwise you don't want to get the information, for example, from the the base model. Okay, because the base model has seen all the data from the internet. When I'm talking about GPT-3 or 4, it has seen everything, right? So it might return you the responses which are from the base knowledge. So maybe you can use a custom prompt template. Only give me from the document. If you have no answers, don't give me any other answer from the base knowledge or something. That's a very good way of getting relevant responses. So let's ask this question, guys. And here you can see we have got the query according to the document. What did Vladimir Putin miscalculate? But it says can only concatenate string, not dictionary to string. So it means this line is giving us error, guys. Line number 39. So we don't have to put answer over there. So let's do one thing. We cannot concatenate. It means it's giving you a dictionary of response. Okay. So let's do that. Let's rerun. So now once we click on ask your query, we should now get the response. Now you can see we have got a dictionary over there. So query according to this document, this is a query that we are asking. What did Vladimir Putin miscalculate? Now here is our result. So if you read the result, according to the document, Vladimir Putin miscalculated the strength of public opposition to his proposed political reform that you were talking about Ukraine, basically, right? But this is not what we want. We don't need this query again, because our query has been shown above, right? We only need the result. So how can we do that? So let's do one thing. So here we're gonna just do answer and just gonna pass the result. So let's do that. So now if I just pass this result, we'll only get the result, we'll not get the query. Okay, so this is what we want here. So you can see, according to the document, Vladimir Putin miscalculated the importance of public opinion in influencing policy. This is the other answer that we got, from the last time. This is the question that we have asked, the document that we have uploaded, a very simple app, combining Langchain with Vectra. Okay, how we can use, and this is not open source model, guys. These are all closed source. Okay, but now depends. Okay, if you want to go with open source, if you want to go with closed source, you can replicate the same exact thing with Azure OpenAI. If you want more control on your data, you can use Azure OpenAI, which is again inside a private VPC. Okay, a virtual private cloud. Okay, you have all the control on your data. My OpenAI will not go and audit or train their models or improve their models on your document if you are using Azure OpenAI. So if you are working at your client place or at your workplace, or if you have a private confidential data, don't use OpenAI APIs, rather use Azure OpenAI services, and just everything will remain the same. Your API keys will be changed, your that endpoint will change. So Azure have couple of other configurations, environmental variable, endpoints, and your location, and then keys that you just have to replace. Everything remains the same in your app. Okay, and you can use Vectra, for example, if you want to use. If you can use ChromaDB, for example, if you want to use. But Vectra as provides grounded generation technique, their patented technology that they have. Okay, a patented technique, I will say, not a technology rather. So this is the question that we asked. Let's open that file so I can also show you that this is the state of union file. So if you can see, it's a text file basically. They're talking about all those things. So let's see it here, guys. So we're talking about Putin here. Okay, and let's see. NATO alliances was created to secure the United States member along with 20 other nations. Putin's latest attack on Ukraine. You can see they're talking about Russia invasion on by Ukraine. We are giving more than 1 billion in direct assistance to Ukraine. Let's ask a question. Okay, so I'm just gonna ask how much money has been given to Ukraine. Okay, let me ask this question and see. I'm just asking this question. I don't know if, so you can see I don't know. So it's giving you don't know, but I know why it's giving you this. Okay, if let's add how much money has been given to Ukraine, according to the document. If I add this, are we getting any other response, or we are getting the same response? Because we are talking about the grounded generation here. This document does not mention how much money has been given to Ukraine. Let's read that. We are giving more than 1 billion in direct assistance to Ukraine. I don't know why we got this answer, guys. Okay, maybe we have to ask some other prompts. Let's try. The Russian stock market has lost 40% of its value. Let's ask this question. What is the impact on the Russian stock market according to the document? Now this is a question I'm asking. What is the impact on the Russian stock market according to the document? The document states that Russian stock market has seen an increase in investment and trading activity due to the recent political and economic reform. This is a surprising thing to me. Okay, so let's come down. Okay, let's ask some other questions. Our economic created, or unlike the two technicals past, the past 40 years, we were told that if we give tax breaks to those at the very top, the benefits will trickle down to everyone else. I'm looking to ask, 4,000 projects have already been announced. Let's ask this question. One last question that we're gonna ask. How many projects have been announced according to the document? It says I don't know. Okay, so now you can see the performance of it, guys. Okay, Vectra, this is what I am doing. Let me know if you are doing something else, if you get any other result, because the creator has claimed a lot of things, okay, about Vectra. That, okay, that it has better features, it has grounded generation, it will give you better responses. But now you can see it in your front. let me know if you are making some wrong prompts, if you are able to improve the performance with custom prompts, and if you are doing some, if you are using some other chains. But for me, when I'm using it for the first time, I don't see anything different here. What we already have in the industry, right? We have been using it a lot of other tools like Pinecone or other vector databases or vector stores. I don't see much differences here, guys. Okay, you can see the answer that we are getting it from here. Okay, Intel CEO who is here tonight told me that they are ready to increase the investment from 20. Let's ask this last question and see. What did Intel CEO said about the investment? No, according to the document. Intel CEO said that the investment would help the company to remain competitive. This is good. Okay, so we at least got the response. We are not getting the exact number because we have to tweak the prompts to get it. Okay, so if I ask the next time, I don't know if we are getting the same response. Okay, let's see if we are getting the same response. No, we are getting some other response. At least it understands. So this is good, but we are not getting the exact thing. We might not have asked the same prompt. Okay, that we are expecting the answers, but it makes sense. So you can see, right, this is what we wanted to do in this video, guys. We wanted to use Vectra. We wanted to explore a new platform that has been released, how we can combine with Langchain. If you have some thoughts or feedback, and if you have your findings, please let me know. I'll be more than happy to, understand the findings from your side as well. And please let me know your thoughts and feedback on this video in the comment box. Okay, and the code will be available on the GitHub repository, guys. Okay, you can find all the related codes, large language model related codes on my GitHub repository, AI Anytime. I have multiple videos on large language models and end-to-end projects as well, a few videos, and you can find that in LLM playlist. So if you like the content, please hit the like icon, and if you haven't subscribed the channel yet, please do subscribe and share this video and channel with your friends and to peer. Thank you so much for watching, guys. See you in the next one.